All right, so today we're going to talk about the intersection of two of my, loves, mathematics and psychology. And, it really goes to show that mathematics is everywhere. And in particular, we're going to look at personality psychology. So we're going to look at different personality traits. And we're going to hopefully come to an understanding of what's called null hypothesis significance testing by working through an example and seeing how you can test whether things are, if there's statistically significant results. In particular, as we look at the means of two different populations and samples. So let's have a look. The question we're going to look at is this question, and these are the kinds of questions that null hypothesis significance testing can answer if you've got the right psychometric tools to evaluate people's personality. And the question is, are women more agreeable than the population? So there's a massive data set out there called the IP Big 5 personality test, and it's freely available at that address there. It's got over 1 million respondents, and it uses Goldberg's 50-item Big 5 markers. I'll just explain the Big 5 personality trait. You've probably done some of these before. It uses the OCEAN model, which is an acronym standing for openness, conscientiousness, extroversion, agreeableness, and neuroticism. And scores on agreeableness range from 10 to 50. So that's what we're going to look at in particular in this video. And I'll put links to these papers below, because essentially we're going to ask ourselves the question, is there a statistical effect there that women are more agreeable than the population? And this is what this methodology can help us answer. So really we're learning about the methodology, but I thought it'd be good to wrap it in an actual example. So that's our question, our assumed population parameters. So just for illustrative purposes, our entire population here is going to be the literal population of the world, so whatever it is, 8 billion people, and we're going to pretend that we know the overall mean. We're going to say that the overall mean on this agreeableness scale, and we'll look at that in a bit more detail in a second, is 35.9 on average for everyone, and the overall standard deviation is 6.6. And we're going to look at the situation where, women's mean from this sample, now this is a massive sample, over 1 million, we get a sample of 37.2. Okay, and these values are consistent with the prior research and this data, blah, blah, blah. So yeah, let's look at this idea of agreeableness just in a bit more detail. So you can sort of think about the kinds of questions that are being asked and how it might look in the real world. So these are the questions. So again, agreeableness is part of the Big 5 psychology test, and so it reflects how much individuals adjust their behavior to suit others. So high scores tend to be cooperative people, trusting, empathetic, and kind. And low scores tend to be people that are more competitive, blunt, and skeptical of other people's motives. So here are just some sample items. Again, you might be familiar with some of these if you've done one of these sort of personality tests before, but the first three are what are called positively scored. So I feel others' emotions. So if you score a 5 on that, then that means you're higher in agreeableness. I sympathize with others' feelings. I make people feel at ease. And then you've got some what are called reverse scored items or negatively scored. So I insult people. If you put a 5 for that, that obviously means you're low in agreeableness. So that 5 would become a 1, a 4 would become a 2, and so on. I'm not uninterested in other people's problems. I'm not interested in other people's problems, rather. Again, that's reverse scored. A 5 would get transferred to a 1. And yeah, you get a score out of between 10 and 50. And yeah, so let's look at the distributions and let's see what they look like. So again, we're going to get these normal distributions. That should be interesting. Normal distributions are something that have come out purely of, the central limit theorem, which we've spoken about before, but you see them appear naturally even in things like people's personality. And this is a very robust finding in psychology. It's been replicated many times, what I'm about to show you, which is this, right? So here are the distributions of agreeableness scores. So in blue, we have the population, and in red, we have women's scores. So the population mean, again, is 35.9, and the standard deviation is 6.6. And for women, we get 37.2 from our really large sample, right? I think later on I say the sample is 500, but if we're thinking about the population being the world's population, then those 1 million respondents where we've collected this data is essentially our sample. for illustrative purposes. But yeah, we can see that the women's score is 37.2 and the standard deviation is a little bit smaller, so there's a little bit less spread than the overall population. So what we're going to do now is we're going to say, all right, is this real? Is there a real effect here? Is there a statistically significant effect? And the way we're going to answer that is through this idea of null hypothesis significance testing for the mean, because we're talking about averages here, right? And a really good analogy, and it might seem like we're taking a bit of a sideways trip here, but is a courtroom analogy. And this comes from the Cambridge textbook. It's a very good textbook. Definitely go and read it and flick through it. And yeah, so it uses a courtroom analogy. So the defendant is assumed innocent until proven guilty in a lot of legal systems, right? And then the prosecutor must provide enough evidence to overturn it. So in statistics, we do the exact same thing. So to be assumed innocent is what we call the null hypothesis. And this has this notation, H sub naught. And that's being assumed innocent. The guilty verdict is our alternative hypothesis, right? That's the alternative to being assumed innocent. If you're not innocent, you're guilty in this situation. And we denote that H sub 1 as our alternative hypothesis. The evidence from the trial is like the sample that we take, right? And the jury's decision is what's called this p-value, which we're going to talk about in detail, versing some criterion, right? So what do they say in courtrooms? They say something like beyond a reasonable doubt. You need to be, whatever it is, beyond a reasonable doubt, that's your sort of criterion for when you can reject the assumption of innocence. And so let's translate that sort of language, that null hypothesis, alternative hypothesis, into the example that we're doing. And maybe you can pause and have a think. What is our null hypothesis in this situation about agreeableness and population scores and all that stuff? So hopefully I think the answer's here, but women's agreeableness, our null hypothesis would be that women's agreeableness scores is no different from the overall population mean. And any observed difference is due to sampling variation. And so our null hypothesis, and this is how we would denote it, is that H naught says that the mean of women's scores is 35.9. And that 37.2 we got, that was just due to sampling variation. We just picked, particularly agreeable women, and actually they're not any higher than the population mean in agreeableness. So hopefully you can start to see what the alternative hypothesis is. The alternative hypothesis would be that women's mean agreeableness scores is higher than the population mean. So we would say that H sub 1 is that the mean of women's scores is greater than 35.9. And now I just want to talk about this idea of what's called an upper one-tailed test. Because there's been a lot of research on this sort of stuff, if you were conducting your own study into this, you would have a lot of evidence prior, based on other people's research, that women's agreeableness scores are in fact higher as opposed to lower than the overall population mean. And so you'll do what's called an upper one-tailed test. If you think about this term tailed, if you think about the tails of the distribution, right? We're thinking that women's scores are going to be in the upper tail of the distribution when compared to the overall population mean. Maybe I haven't phrased that properly, but that's the idea. We're saying we've got what's called a directional hypothesis, as it says here. And a one-tailed test is appropriate when the direction of the effect is specified before data collection. So this is what's so interesting about using hypothesis testing in the real world. You have to sort of bake in your assumptions about what's going to happen before you run the statistical tests. Otherwise, you risk seeing effects that don't exist and all sorts of things like that. So let's look at the mathematics of this example in particular, and just wait for it to load here. So now we're going to talk about this idea of p-value, and I just want to pause on this for a second. I'm even going to go back a bit. Where are we going to go? There we are. So the p-value, and this is something I didn't understand for a very long time, okay? But hopefully this will explain. So the p-value is the probability of observing a sample mean as large or larger than the one obtained, assuming that the null hypothesis is true. So in our example, right, we're interested in assuming that the null hypothesis is true, assuming that women's mean does not differ from the overall population in agreeableness. How likely are we to have seen that score of 37.2? And so this p-value measures that as a probability that we see that score or larger, given that the sample was taken from the overall population, right? So let's look at the mathematics of that, because it can all be written very, neatly and mathematically, and it uses a lot of this fun stuff. So starting from the top, H0 is our null hypothesis. It says that women's mean is 35.9. What we saw of 37.2 here was just statistical noise. It was just the fact that, you might have got a particularly agreeable sample, right? And then so what we're going to do is we're going to test, is there a statistically significant effect? And so one of the things we need to do is we need to work out the standard error. So the way we talk about the standard error, and this is all stuff from the central limit theorem video, which I'll put a link below. If you haven't seen that and you've gotten this far and you're not sure about all that, definitely go back and watch that. But basically you take the standard deviation, the population standard deviation, over the square root of the sample. So you get 6.6 over square root of 500, which is 0.295. And then basically our p-value is this. It's the probability that we see a value greater than or equal to 37.2, given that the mean is 35.9. And so we're asking, what is the probability of that conditional statement, right? And so we standardize, and we've spoken about standardization again in another video. So we standardize our z-score. So we get the probability, sorry, I should say the way that we standardize is we take the score that we got from the sample, which is 37.2, we take away the mean. So that sort of tells us our deviation from the mean, and then we divide by our standard error, which is 0.295. And then this gives us a value of 4.41. And now hopefully that's screaming out at you as being very far into the distribution, because let's just remind ourselves about the standard normal distribution. It has a mean of 0 and standard deviations of 1. It's something like 69% of the data is within two standard deviations. Is within one standard deviation. By the time you're at 3 standard deviations, you've got like 99.9% of the data or something like that. And so to be greater than 4.41, you're very far into one tail of the distribution. And so your p-value is absolutely tiny. It's less than 0.00001, which is essentially 0. And so our interpretation is, if women's mean is 35.9, the probability of seeing this score that we did, 37.2, from our sample of 500 is essentially 0. It's so small that we can reject the null hypothesis. Women are significantly higher, and when we say significantly, we don't mean lots, we mean statistically significantly higher than the population mean in agreeableness scores. That doesn't mean it's meaningful, but it's statistically significant because they're very large samples, and we'll talk about that in a moment, what large samples mean. So yeah, this interpretation box is the core of it, right? So we are seeing something that's statistically significant in this data when we compare the mean of the population, the mean of the women's scores. Okay, let's keep looking. So statistical significance. The smaller the p-value, the stronger the evidence against the null hypothesis. Okay, so these p-values need to be compared against some sort of criterion prior to doing your analysis, right? So this is where we need to compare it against this alpha criterion. Alpha, again, needs to be decided before you start. And so commonly in psychology, alpha is 0.05. So if p is less than 0.05, then there's less than a 5% chance that what we're seeing is, I need to phrase it properly. If p is less than 0.05, then there's less than a 5% chance that what we're seeing is, let me get it right. One more attempt. If p is less than 0.05, there is less than a 5% chance that what we're seeing is due to sampling variation, which means that there is a real effect that we're observing in the data, right? And so, in psychology, depending on the field of psychology you're in, you'll use different criteria for what alpha is. Generally, as I said, it's less than 0.05 is pretty good evidence against the null hypothesis. Less than 0.01 is strong evidence against the null hypothesis. Less than 0.001 is very strong evidence against the null hypothesis. Our result was p less than 0.00001. So we can be very confident that we're not just seeing sampling variation and women having higher agreeableness scores. We can be confident and we can reject the null hypothesis at any conventional alpha. That just means at any criteria that you set. 0.05 is usually, a reasonable alpha. And we've got much less than that. So we're seeing we're seeing a statistically significant result here. There's no doubt about that. And, we need to then be careful about how we interpret these things, right? So there's what's called statistical significance versus practical significance, right? So far up to now, we've been talking about statistical significance. And that is just this, part of this idea is that, you've got a massive sample. We've got a million respondents. Almost any difference will produce a tiny p-value. Statistical significance just tells it that the effect is unlikely to be zero. Practically, though, we need to think about, is this a meaningful difference? The two distributions, as we saw, they overlap substantially. If you go back to that, scene we had before. Most women and most men are indistinguishable on this trait. If you pick a random person from the population, you are not going to be able to say much about their mean agreeableness. You're not going to be able to say much about their agreeableness scores. In fact, a statistically significant result can be practically quite small. So gender, so male or female, only accounts for 5% of variance in agreeableness. So you need to do a multi-factor analysis of agreeableness to understand more about what contributes to overall agreeableness. But gender clearly is one of the factors. And the last thing is just what's called the large sample trap. So with a large enough sample, we can detect differences of any size, even one too small to matter in practice. So is it significant? Yes, in this case, it's definitely statistically significant. Is it meaningful? Well, not really. Hopefully making some sort of sense. Just a summary here, I believe. So, this is how you do null hypothesis significance testing. Hopefully the example was useful. So for an upper one-tailed test, upper one-tailed z-test. Now, the reality is a z-test is when you know the population parameters. In reality, you'll do what's called a t-test in most psychology studies. But we just looked at upper one-tailed z-test. We'll look at two-tailed tests in a little bit. So that's when you're not sure of the direction of the hypothesis. You're not sure, whether women are going to score higher in agreeableness or lower in agreeableness. Let me choose a different example. Maybe extroversion. So sort of like a measure of outgoingness. You're not sure if women are going to score higher or lower on that. Then you would do what's called a two-tailed test. And again, you have to do these things before you do your statistical analysis. And then you compare it to, you standardize the data, and then you compare it to your criterion that you've set, usually alpha being at 0.05. If it's less than alpha, then you can reject the null hypothesis. Is there anything else we need to add there? Yeah, we spoke about the result. It's statistically significant, but it's not necessarily a meaningful difference. And as we saw there, the raw score difference between the overall population and the women's was 1.3 points. So it's a large overlap that reminds us that statistically significance does not mean that it's a large. It does not mean that it's a large difference, but it is statistically significant difference. All right. Hopefully you found that useful. Give us a thumbs up if you did. Good luck with whatever you're doing, because this is for specialist maths, but hopefully it was useful for anyone that's studying social sciences and wanted to know a little bit about null hypothesis significance testing for the mean. Let me know what you think. Happy to chat, and good luck.